To see it in action, I'm back in our REST API project we created earlier, where we previously added socket.io. And first of all, I'll get rid of that socket.io part. I'll remove it. I'll remove the socket.js file. In app.js, I will also remove my routes because we'll have no more routes. We'll not set up routes anymore. We'll use GraphQL endpoints instead. I'll leave the rest as it is for now. Remove that code where I use my routes. And then here, I will not store the server because I will not set up any socket.io connection. And we can also now remove the routes folder because we'll not use that anymore. So now I cleaned that up a little bit, and now I want to use GraphQL. And for that, I'll install two new packages. The first one is called just GraphQL. This will be required for defining the schema of our GraphQL service. So basically the definition of the queries and mutations and so on we want to allow. And I will also add Express GraphQL to install a simple server that will do the parsing of incoming requests and so on. Now, if you want to learn more about GraphQL, check out graphql.org. It's a great resource with a lot of documentation on GraphQL and its query language, which, by the way, is clearly defined, and we need a strong rule set to know how we write queries. And there, if you click on code, you also find libraries for all kinds of languages. And if you choose JavaScript, you find the GraphQL package we just installed, which allows us to define such a schema as I mentioned. You find Express GraphQL, and you also find other solutions for other frameworks. Apollo, for example, is super popular and works with any Node framework. It offers more than the bare bone setup Express GraphQL gives us though, and I want to show you a very raw approach in this module so that you understand all the behind the scenes things. Apollo would hide some of these things, so I will instead use Express GraphQL. Now, with that out of the way, we installed that, we cleaned up our project. Now let's add some GraphQL logic. Now, how do we do that? First of all, I'll create a new folder named GraphQL where I will put my GraphQL related code. And there I'll add my schema.js file where I define the queries, mutations, and types I work with in my GraphQL service I'll create. And I'll add a resolvers.js file where I will define the logic that is then executed for incoming queries. Now in schema.js, let's start with that. There, I'll first of all import something from that GraphQL package I installed. Not from Express GraphQL, but just GraphQL. And that something I import is the build schema function, which allows me to build a schema which can then be parsed by GraphQL and by Express GraphQL. I will export this schema, so I'll use module exports. And then I will call the build schema function, and I will return that schema object this will generate for me. And now here we pass a string where we describe our schema. Use double backticks here, so not single quotation marks, but backticks to create a string literal, a template literal, because there you can simply write multi-line strings. And now to define a GraphQL schema, in this string we type schema and add curly braces. Please note that there is no colon after schema. And in that schema, we now define a query field. And this now will be an object with all the queries, and queries are the parts where you get data. So all the queries you want to allow. To make it easier to read, I'll now add a separate type for that with the type keyword, which I'll name query. You could name this differently. You could name this root query, however you want. Now in there, you will have all the different queries you can make in the end. For example, you could add one that is named hello, simply a basic dummy query here. Hello, which, let's say, returns a string. This is how you define the return type for a query. You add a colon after the query name, and then the type. And GraphQL knows a couple of types: strings, integers, floats, booleans, IDs, and you can learn all about that in the official docs, of course. So now this is my root query, and this is the return type of my query here. This is now a very basic schema where we can send a hello query to get back some text. Now, that some text now is defined in the resolver. The resolver is an exported object where we now need a hello function, a hello method. So you need a method for every query or mutation you define in your schema. And the name has to match, of course. I have a method named hello here because here I have a query named hello. You don't need a resolver for this query because in your schema, you basically set up your root query, which is then made up of these subqueries, which now need resolvers. So now we have a resolver for hello, that hello method. And there we need to return a string, right? We expect a string. You can, by the way, also make this string required by adding an exclamation mark. Now, if you don't return a string, you'll get an error. So here, I could return hello world, like this. If I now save that, I have a very simple GraphQL service. Now, before we test it, let's make it a little bit more complex. In my schema, I'll add a new type, and I'll name that test data. The name is up to you. And there I'll have a text, which is a string, and I'll have a views property, which is like, say, an integer. Both are required. Please note there is no comma after these fields. You simply use new lines. And now let's say my hello query should return that test data instead of a boring string. Well, then we can go back to the resolver, and now we need to return an object in there with a text field that should be a string, hello world, and with a views field, which should be an integer. Now we have a valid resolver, we have a valid schema. Now we need to expose it to the public. And that can be done with the Express GraphQL package. In app.js, we now import that. So here, I'll import GraphQL HTTP. You can name this however you want, from Express GraphQL. And let's now scroll down all the way to the error handling middleware. And there, let's add another middleware so that all the other middlewares do apply. And here, I will apply this to /GraphQL. And you could change that, but that is a common convention to use. And I deliberately don't limit this to post requests here. And I will show you why in a second. So please make sure you use here. And then you use that GraphQL HTTP method, which is provided by Express GraphQL. And you pass a JavaScript object to it to configure it. Now, this needs two items to work. The first is the schema. And for that, we need to import the schema, which we export in the schema.js file. So here, I'll import GraphQL schema by requiring it from GraphQL schema. And I need to import my GraphQL resolver by importing it from the resolvers file in the GraphQL folder. Now we can go down and use the GraphQL schema here as the schema. And we also need to set the root value, which now points at our resolver. So this is now the GraphQL resolver. With this setup, we can start our node server here. And now let's try this out. You might remember that we have to send post requests, right? So let's use Postman for testing. There, I'll send a request to localhost 8080/GraphQL, and that should be a post request. Now in the body of that request, we send some JSON data that describes our query. So we set this to raw application JSON. And here, you send data like this. You send a JavaScript object with a query key. And this does not mean that we send a query and not a mutation. It simply is something which the Express GraphQL package will look for. Inside of these curly braces, you now write the real query, but actually here, this is a string. And then the value here, between double quotation marks, is your GraphQL query expression. And there, you add curly braces, and in between the name of the query you want to target. And if we have a look at our schema, we see that we have a hello query. So we can target hello here. And hello returns us test data, which has text and views. Now we need to define which data we want to get back for that query. And therefore, after the name of the query, we add another pair of curly braces, and in between, we list the properties, the fields we want to get back for that query. We simply separate them with blanks. So here, I could get my text, for example, but not the views. If I now hit send, indeed you should get hello world here. And if you add a white space and then views, you will get the views too. And this shows you the flexibility already. It's one and the same endpoint, but we define which data we want to get on the front end. And it's important to understand that we don't filter the data on the front end. It gets filtered on the server by Express GraphQL in our case, which does the heavy lifting here. And we simply define our schema and the resolver. In the resolver, we return all the data, but then GraphQL on the server will filter out just the data that was requested by the client. This is how GraphQL works in a nutshell. Let's now see how we can add a mutation. Welcome to this module. The best things always come at the end. In this module, I want to dive into an exciting piece of technology with you. We'll dive into GraphQL, an alternative to building a RESTful API that you would use in the same scenarios. So when you have a decoupled frontend and backend, you will not render views with a GraphQL API too, but it provides some significant advantages over REST APIs, at least in certain scenarios. So in this module, we'll explore what GraphQL actually is and how it compares to REST APIs. And you will learn how to use GraphQL, of course. We'll actually take our existing project and turn it into a GraphQL API or use a GraphQL API. A very exciting technology. I'm super excited to get started with it, so let's dive in. Did you try it on your own? Well, let's wire it up together. For that, in the front end, we need to go to the login handler, which is where we do login users. In the login handler, I need to send a request to /GraphQL, of course. It's a post request. And now I'll define my query. So my GraphQL query. You can name this constant however you want. It's a JavaScript object with the query keyword, and then a string that defines the query. And for a normal query, you now don't repeat query, you just start right away with the curly braces, as we did it in the graphical interface earlier. Now, let me split this over multiple lines to make it easier to read. In that query here, I want to reach out to my login query. So to that query, I defined in that schema, login. I need to pass email and password here. So login actually gets curly braces here. And the email, between double quotation marks, will be the email I also extract down there, of data email in this case. The second argument, separated with a comma in this function-like call here, is the password, also enclosed between double quotation marks. And there you inject of password, of data password. Now, we can get back some data, which we enclose between curly braces. And the data we get back, well, there I'm interested in both the token and the user ID. So I specify both between these curly braces here. That is the query I want to execute, and that is the data I pass to JSON stringify on my request body here. Now, as you learned, checking the response like this will not work. Instead, we can grab the code we used for signing up, this code here, and copy that over in the login handler. We therefore remove these checks in the first then block. In the second then block, we now add the copied checks. And here I just will say user login failed, because creation doesn't make much sense here. Thereafter, we set the state, and the way we retrieve data from the response will not work. I can already say that. Now, why will it not work? Well, for that, let's first of all run the query in the graphical interface. There, let me get rid of that mutation. Instead, let's run a query. You can also omit this, by the way. And in there, it only sees hello. I need to reload. It now sees login. Let me specify the valid email, which I did use for the user, and the password. And now I want to get the token and the user ID. If I now hit Control Enter, I do get my data here, and I do get it on an object which has a data field that is always added by GraphQL. In there, I have the name of my query, which was login, and in there I have my response data. So this is my REST data object in my React code though. So REST data will be this entire object. So if I want to get the token, I need to drill into it, into data login token. So in the places where I just access REST data token, I instead need to do REST data login token. And that is now the case for all the places where I retrieve something from the response data. I need to add data login. With that in place, if I now save that front-end code, and the backend should be saved too, of course, we can go back to our app and try logging in here. And indeed, we then get an error for fetching the posts, which makes sense because we try to use a REST API URL, which does not exist. But logging in actually succeeded. So we got user sign up and log in place. We now need to add some routes for, or some endpoints for getting posts and for adding posts, of course. And we then also want to use that token we do get to protect certain, but not all, GraphQL endpoints. These will all be steps with which we continue. Now that we have users in place, let's work on posts. And for now, I will add posts without a real image, because the image upload is something I'll manage differently. For a post with just title, content, some dummy text for the image URL, and an attached user, you can definitely try this on your own, though that will be challenging, of course. But give it a try, go as far as you can, and then try to solve it together with me. I will, of course, now also do it with you. So I will start in my backend, in my schema here, and I will add a new mutation, create post. There, I expect to get some data that describes the post. We could either get it all as separate arguments, or again, we define an input type, which I will do here, and that will be my post input data. And in my post input data here, I will require everything I need to, well, create a new post. And I expect that to be a title, which is a string, the content, which is a string, and also the image URL. The user is something I can retrieve from the token, which has to be attached at some point anyways, and the image upload is something we'll handle differently later. So the post input data is in the end what I get here. So post input will be of type post input data, and I will return the created post here. Remember that we did create that post type earlier already. And now with that, we can actually already move on to the resolvers and add a new resolver, which I'll name create post. In there, I can use destructuring to extract my post input argument, which I just defined in my schema here. And I do get the request as the second argument. We'll need that later to get the user data. Now, for now, let's simply create a dummy post with the dummy data we are able to use right now. And of course, let's also validate the input. For validation, I'll use the same approach as when we created or logged users in. I'll create an empty array, an empty errors array, and then I'll add a couple of if statements. Here I'll check if validator is empty. Is empty. So if the input is empty, and I'll check that for my title. If that is the case, or if we don't meet a minimum length requirement with is length for the post input title, and then I configure this length with the second argument to be a minimum of 5 characters long. If we have either of these two cases, then I'll push a new object onto my arrows array with a message of title is invalid. Obviously, again, you could be more detailed here. So that is my title validation. I'll then add another if check where I check the content for exactly the same two things. And that is it for now. Now with that in place, I'll keep my code I have up there where I have a look at my error's length. And I will copy that down here too, to throw an error if we have any validation errors. If we make it past this if block here, I know my input is valid and we can now create a new post. For that, we'll eventually also need a user, but for now, I'll ignore the user. And instead, here up there, I'll import my post mongoose model from the models folder. And now we can use that to create new posts, which you of course do. Whoops, not user, post, by using our constructor mongoose gives us. Now I want to use async await again, so I'll tweak that to use this syntax here. And now down there where I create my, whoops, not user, my new post, I pass in the title, which I get from post input title. I of course also add the content here, so post input content, the image URL, post input image URL. And for now, I won't add a creator here because I'm not able to retrieve the user yet. So that is my post. I can now store the created post in a new constant, and I get that by awaiting for post save to finish. Here, I'll then also need to add post to users posts later once I do also retrieve the user. For now, I can just return my response here, so to say, by getting all the data from the created post doc, and then I'll overwrite the ID because I can't return the MongoDB object ID. I need to return a string. And I also will overwrite created at and updated at because these will be stored as date types. GraphQL does not understand that, so I need to convert that to a string too. So I get that from my created post, there, created at, and I need to call to ISO string here. The same for updated at. Updated at will be created post, updated at to ISO string. And now with that, this is the data I want to return when a new post was added. Now for now, I'm not checking if the user is authenticated and so on. I'll just have this resolver added, this create post resolver for the respective mutation. Let's try it out in GraphQL first of all. So here, if I reload that so that it loads my latest definition, I can add a mutation here. And that is now create post. There I have my post input, which is an object, where I have a title, test, where I have a content, test, and where I have an image URL, some URL, and where I then, once it is created, can get back the ID and the title, let's say. Let me click on Prettify to make this a bit easier to read. And now if I hit the play button, I get invalid input, which makes sense because title and content are too short. So let's make them 5 characters long. And now I simply get an error from the database that the creator is missing, which makes sense. But the general mutation is working. Let's now make sure we also validate that token, which we need to send anyways, and that we extract the user ID and the user therefore, so that we can connect posts and users. And thereafter, we'll of course also connect our front end. The basic create post mutation is in place, but now we need to be able to validate our token and extract the user from it. And that is not too far off on how we did it in a REST API. First of all, we need to ensure that we send the token in a header of our incoming request. And if we have a look at our front-end code and there at feed.js, which is where we do create new posts, we do that in the finish edit handler. There we do indeed attach our token to the outgoing request. This is still the wrong URL here, but this is how we will send the request in the end. So we'll have that token in the URL. And previously in the REST API, we used the isOff middleware to get our token from there, validate it, extract the user data, and add the user data, the user ID, to the request object. And that is pretty close to what I want to do now. I will just tweak it a little bit. I'll name it auth because it's not just there to validate authentication. It will also give me the user data, but that is something purely cosmetic. In there, I will still, first of all, get my auth header. I'll check if it is set. And if it is not set, then I will do something different though. I will not throw an error. Instead, on my request, I'll set isOff to false so that I can handle this inside of my resolvers. And then I will return next to continue with the next middleware and not execute the other code here. That is why I also have the return statement. If we do have the auth header, we continue, we extract the token as before, we try to decode it just as before, make sure this key here matches the key you used in your resolver for signing the token, by the way. If these two don't match, you have no chance of validating your token. We catch an error, but if I get an error, I again don't throw it. Instead, I set request isOff to false and return next here too, to not execute any other code. If the decoded token is undefined, I also throw no error. Instead here, again, I set isOff to false and I return next. And if I make it past all these checks, I will get my user ID from the decoded token, and I will set isOff to true, so that is a new property I add to the request, and I call next. Now this tweaked middleware is something I add in app.js before my GraphQL endpoint. So here I will simply import that auth by requiring it from middleware auth. This is my middleware, and I will add it here like that. This middleware will now run on every request that reaches my GraphQL endpoint, but it will not deny the request if there is no token. The only thing it will do is it will set isOff to false. And then I can decide in my resolver whether I want to continue or not. And this is the next step. In my resolvers, there, I don't care about isOff and create user and so on. So there I will just not do anything with that information. In create post, here, I will first of all check if request is auth, if that is not true. Because then I know, hey, the user is not authenticated. I certainly don't want to grant access to creating a post. So if the user is not authenticated here, then I will create a new error, not authenticated. And I'll set a code of, let's say, 401, and then I'll throw my error. And therefore, the other code in this resolver here will not execute. If the user is authenticated, we can continue. Then we validate the input, and then before we create the post, we can now also get the user from the database. Because remember that we do store the user ID in our request as well. So in the resolver, right before creating the post now, I can get my user by awaiting user find one, or not find one, I can actually use find by ID, of course, and there I pass in request user ID. So exactly the thing I'm storing here. I passed it in, and now I get a user. If I don't get a user here, then something is wrong, and I will throw an error. So here, invalid user maybe. Set the code to 401 and throw that. But if we make it past that, we have a user object with which we can work. And now on the newly created post, I can set the creator equal to my extracted user. So to the user I got from the database. Once I created the post, I can now also use that user and access the posts of that user to push the created post onto that list of posts. So to set up that connection. That is now it. And now we need to work on the front end to also send a request to this endpoint so that we can see that in action. On the front end, in the finish added handler function in the feed.js file, there, I'll ignore the image upload for now. I want to now reach my GraphQL endpoint and create a new user. For that, first of all, I will get rid of this code because I will not send this request to different URLs anymore, and I'll not use different methods. It's always the same URL and the same method. Localhost 8080 GraphQL, and the method simply is post. The body is also not my form data, but here I'll create a new query with let because this will change when we edit the post later. And my query here is GraphQL query. My query here is defined as before, query. And then this is a multi-line string with backticks. It then actually is a mutation, and the mutation is create post. To that, I need to send the data I did on my graphical user interface. So actually, I can copy that here, move that over there, and now replace these hard-coded values with dynamic values. So here, for the title, I will pass post data title. For the content, I will pass post data content. And for the image, I'll keep that to some URL for now until we have a real image. I get back the ID and title. Now let me, first of all, send this in a stringified version, the GraphQL query. And then let's do something with the response. Now again, this way of handling it will not really work. So let's instead copy the code. We use an app.js where I check for errors on the extracted response body. And therefore I do it here. Then I log my response data, and you see I'm interested in the ID, title, content, creator, and created at here, so I should actually retrieve all of that. So in my query, I get the ID, title, content, image URL, creator, and created at date. By the way, the creator, if you have a look at my schema, is again a more complex object. It's a user object. So for the creator, we need to be more specific, and that is the cool thing about GraphQL. We can really drill into the data. And here, let's say I'm only interested in the name. And indeed I am. I don't care about the ID or email. In this scenario here, I want the name so that I can render that onto the screen next to my posts. And this shows the power of GraphQL really well. We get exactly the data we need. Well, now with that, we sent the post request. Here, for extracting that data, we'll have some problems. But first of all, let's focus on what we logged to the console and see if that works. So back to our application. I am still logged in because I have a valid token. And I do still attach this token, by the way, here. But we also need another header. We need to add the content type and set that to application JSON. That is required. So make sure you add this. And now back in the application, click new post, add a duck. You have to choose an image here, even though it's not uploaded. Otherwise, you can't submit. And then I'll add my lovely duck. And here, I get an error, which was expected. But I also see a console log, which actually doesn't look too bad. I do have all the data I entered, and we can now have a look at MongoDB Compass. And there, if I refresh this and look into my posts collection, I indeed see a post with the data I entered, with that creator ending with AA1. And if I have a look at my users, I see that is that user, and there on the posts, I'm unfortunately missing my post. So that is one thing we'll need to tweak, but the rest is already working really well. Let's make sure we add that post here too. And then, of course, let's make sure we extract the data on the front end correctly so that we also render that post. For that, by the way, we'll also have to make sure we load all posts initially though. Now let's first of all fix the fact that our user does not have the post added to his posts array. The reason for that is that I do push the post here, but of course I forgot one important thing. I never saved that change. I need to call user save here, and I'm not interested in the result, but I certainly want to await it nonetheless, so that I only return after this has been done. So this is one important change, and this is only one change we need though. We can quickly validate whether it works, however, by going to posts. Let's delete that post which we added here. And now let's go back to our front end, add a new post, another duck, choose an image even though it's not getting used. Let's add some content and click accept. We still get that error, but if we go back to Compass and we have a look at our users, for the first user, we now also see that post here. So that is now working. And now let's make sure we also extract the data correctly on the front end, and that we then also load all posts so that we really can see them there. Now for the data extraction, we see that this is the data in the format we get it back. An object with a data field, then the name of our query, and then in another nested object, the fields for that query. And this is exactly how we have to retrieve our data. So in our React code, in feed.js here, when I create my post there and I try to access response data post, this will not work. I have to access rest data, data, create post. So here it's rest data, data, create post ID. And that is the case for all these places, where I do access fields on my created post. Now with that, we should not get an error message anymore when I create a new post at least. So let's try that out. A cup. Let's choose the cup image, though it does not matter. We're not uploading it. Hit accept, and I don't get that error anymore. So extracting the data works. Now let's focus on adding a query that allows us to get our posts so that we can also render them here. This is also a great practice for you. We'll do it together in the next lecture. Try fetching your posts on your own. Try creating that query on the backend on your own. You don't need to tweak the front-end code. If you can do that, perfect. We'll do it together otherwise. But add your GraphQL query and test it with the graphical interface. Let's make sure we can now also get all posts. And for that, I'll start on the backend in my schema again. Getting, that of course is a normal query. So next to login, I'll add a query and I'll name it posts. You can name it however you want. I don't need any arguments here. I instead can directly define my return type, and that will actually not be an array of posts as you might have expected. But actually, I'll create a new type for that. Because remember that in the REST API, we also did not just return an array of posts, but for pagination, also a number that specified our total amount of posts in the database. So I will create a new type, and I'll name it post data, which now has a posts key, and that will be my array of posts. And I'll also have a total posts field here, which will be an integer. Now, post data is what my query here should return. And now we need a resolver for that. So let's head over to resolvers, and there I'll add posts. I'll write this as an async function like this. I will actually not care about the first argument for now, my args, but I will need the request to find out whether the user is authenticated. That is actually the first thing I'll check, and I'll copy the check from create post, this if statement here, and I'll add it here. Now, if the request is not authenticated, if the user is not authenticated, I'll throw an error. Otherwise, I'll later add some pagination logic, but for now, I want to find the total number of posts and then all posts. So total posts can be found by awaiting post find. This gives me all posts, and then count documents. The posts themselves can be found by using await on post find like this. And again, later I will also add skip and limit. For now, I'll only add sort, and I will sort by created at in descending order. I will also populate my creator to fetch the full user data with the name and so on, because I'll need all that on the front end. So here I got my posts. Now we can already return some data. I'll return an object, and that object has to look like I defined it in my schema. So it has to be an object with a posts key and a total posts key. So in that object, I'll add posts, and that will be the posts I fetched here, and total posts, which will be total posts. Now, posts will not be returned like this, because in there would be fields like _ID or created at, which hold data formats that are not understood by GraphQL. So instead, I will add map here, and you learned about map, for example, in the JavaScript refresher, which allows me to transform every element in that array. So here, I will return a new object for every post, which will generally be the same. So I will pull out the existing elements on the post document, but then I will override the ID with p_id to string to return a string. And for created at, I will use p created at to ISO string, and the same for updated at, where I will use p updated at to ISO string. And this is now how I will transform my posts, every single post in the posts array, and therefore the overall array. This is the backend. This is the schema and the resolver set up for getting posts. Now let's test this on graphical. Here, let me reload that page. And there I will run a new query, which will be called posts. And let's say there I'm interested in both the posts and total posts. Posts is an array of complex objects. So there I also need to specify what I want to get out of there. Let's say I'm interested in the ID, the title, and the content. And now I hit Control Enter, and I get not authenticated, which is correct because I'm not sending a token here. So that is the next step. We'll send this request from the front end, add our token, and then, of course, also render our posts. So let's use that query here from the front end. And for that, I'll go to my React application, of course. There, the feed.js file. And here we have to scroll up a little bit to load posts. There we have some pagination logic, which we can ignore for now. And then I'll write my GraphQL query here, which is a JavaScript object, where I have a query, which now is that multi-line string. And in that multi-line string, I now will start with curly braces right away. And in there, just as I did it in graphical, and therefore we can, of course, again, copy that, I'll look for posts. This is the name of my query. And in there, this happens to return this post data object, which has posts and total posts. And for every post, I'm interested in the ID, title, content, image URL, also creator, and also created at. Creator, again, is a complex object, and there I'm interested in the name. So this is the data I need to render my posts efficiently. Now to run that query, let's change that URL down there. And you know which URL that is. It's localhost 8080/GraphQL. The method will be post, of course. Headers is the token, but also the content type, which should be application JSON. And of course, I need to add my body here. And that body will be stringified with the JSON package. And that will be that GraphQL query I wrote up there. And please note again that we see the entire flexibility of GraphQL doing its job here. We're fetching exactly that post data we need. We don't fetch things like the creator email, which we don't need. We don't fetch the updated add field, which we don't need. We only fetch what we need. And we actually don't even need the image URL here, now that I think about it. We're not rendering that image on that starting page. So really, we only fetch what we need, and we use GraphQL to its fullest potential here. But back to our request. I'm now sending this request. Now, again, handling errors like this will not succeed. Instead, we want to handle it as we did down there. We don't need to check for validation errors, though, because in this query, we can't send incorrect data. So we'll simply check if we got any other errors. And I'll then say fetching posts failed. And otherwise, we'll have our posts. And we can't access them on REST data posts, though, as you know. Instead, if we have a look at our schema, our post data will be found on data, then posts, because that's the name of the query. That will be an object of this type with another field of posts in there. And then we can drill into our post data. So here, the posts, the final posts can be found on restdata.data.posts.posts. This is the query, and this is then the posts field in the return data of the query. And then we can let React do its job. For the total posts, it's all the rest data, posts, and then it's not total items, but total posts. I renamed that on my backend. If we now save that and we go back to our React application, we can already see it. That error is coming from the user status, but behind that we see our posts are getting rendered. We see the username, so that is all working. And now let's also add the code to add a new post to this page immediately before we then also add pagination and then also have a look at how we can get our image onto the server. So let's quickly add the code to add a new post immediately. We do that in the feed.js file of the front-end code in the finish added handler. And there we scroll down to the place where we create our post object. We're not actually doing anything with that thus far, so that's time to change. So there, with this post, I prepared some code which you can now use. You can just copy it in and replace the this set state statement with the attached code. And thereafter, go back to your application and add another cup, for example. Also hot, and hit accept, and you see that cup here too. Pagination is not working, but we'll take care about that later. For now, we can add that, and we can load our posts in general. Now that we're able to fetch our posts through GraphQL, let's add pagination again. How does that work with GraphQL? Turns out, not too difficult. We start on our GraphQL schema again, because there we'll need to change something on our posts query, because it is the posts query where we want to add pagination, right? We want to be able to paginate through all the posts. Therefore, the posts query needs an argument. It needs an argument that allows us to define the page we are on. And I'll name that page. You can name it however you want. And this will be of type integer. Now, with that argument added in the schema, in our resolver, we can implement pagination. There, in my posts resolver, my arguments now will have that page property, so I can retrieve it with destructuring. And after checking whether I'm authenticated or not, I now need to set up pagination, or I need to find out which page I'm on and use that. Now, first of all, I'll quickly check if page, if this is not set, because if it is not set, so if it is undefined, I'll set it equal to 1, so that I always start on page 1 in case I don't specify any other page. As a next step, we can define the per page variable, which is 2, as it was in our REST API scenario. You could theoretically also fetch this as an argument. I'll hard-code it here for simplicity reasons, because this would primarily something we would have to manage in the front end with a drop-down offering the user different page sizes and so on. So I'll hard-code it here. And now we have per page, we have the current page. Now we can use that here when we find the posts. And you already learned that you can paginate with skip and limit. So skip and limit is what you can add here. And in skip, you want to skip your current page minus 1 times per page. So if you're on page 2, you have 2 minus 1, which is 1, obviously. And you skip 1 times 2, so the first 2 items, the 2 items that were on page 1. You don't just want to skip, though. You also want to limit. And you limit the result set to the amount of pages, of items you want to render per page by adding per page as an argument here. And that is it. This is pagination in place on the server side. Now, in the front end, there we already have some logic for the pagination. If we go to load posts, there I do already get my page variable. Now I just need to send that with my query. And for that, on the posts query, I can set page equal to, well, the page I calculate up there. Since this is a number, I also don't need to wrap that in double quotation marks. Let me save all that. Also make sure the backend code is saved. And let's reload our frontend application. Whoops, for that I should restart the server. And indeed here, I got pagination in place. Now when I add a new post, to make sure that it does not show up as a third element when we only want to have 2, I will go back to my React code and there to the finish edit handler. And here in set state, where you find that unshift statement, simply add updated posts pop in front of that. And that is all. This will remove one element and add the new one at the beginning. And now let's give this a try. Let's add another duck. Choose the duck image. Also very lovely. Accept this. And here is the another duck, another cup. Here is the rest. And this is exactly the data we find in the database too. We got 2 another ducks, just in the case you got confused. So this is working. Let's now work on the image upload, because that obviously is something very interesting which we haven't touched on thus far for our GraphQL API. How does uploading data work now? The thing is, GraphQL only works with JSON data. You can find a couple of articles, third-party packages that help you with getting data through GraphQL. But in the end, one of the cleanest solutions is to use a classic endpoint, like a REST endpoint, where you send your image to, and then let that endpoint store the image and return the path to the image, and then send another request with that path to the image and your other data to your GraphQL endpoint. And this is the solution I'll implement here. I'll implement it in app.js, because you could outsource this into a separate file, but it'll be the only other route we add here. And there I'll register a new route on my app for incoming put requests, because I plan to send that image with a put request to / let's say post image. You can name this path however you want. There we have our traditional middleware function. I hope you still know that, even though we haven't used it in the last lectures. And there I'll first of all check if we don't have a file. Now how can I check that? Well, I still have Malter in place. We added that in the REST API module, and Malter is the package which takes our multi-part form data requests and extracts a file and stores it in the images folder. And I still have that in place. So all my files still will be extracted, and Malter then populates the file object with information about the extracted file. Now, if this is not set, then I'll just return a response here with a status of 200 and a message where I say no file provided. You could set an error code here, but actually this scenario is fine for me, as you will see when we later edit a post, because there we might or might not add a new image. Maybe we stick to the old one, maybe we did choose a new one. And then this is one way of handling both cases. If we do have a request file, we can get some data from it though. And of course, we want to clear an existing image if there is one. For that, I'll create a new function here, or actually I have that function in the feed.js controller already. I can copy that from there. The clear image function at the bottom of the feed.js file. I'll move that into app.js. This depends on the fs package and on the path package, the path module. Path is already imported. Now I'll also import fs here. And now with that all imported, back in our put request here, I'll check for the existence of a body field which is named old path, which simply means that an old path was passed with the incoming request, in which case I want to clear my old image and I'll pass in the old path, because then we added a new image. We can be certain about that after this if check. And then we should also have an old path, which we delete so that we don't keep the old image and the new image. Instead, we delete the old image here and then only keep the new image, which was stored by Multer. And then at the end here, I will return a response with a status code of 201. And that differentiates it from this response. And here, I will add some JSON data, let's say a message, file stored, but more importantly, I'll add a file path, or however you want to name it, which is request file path. And this is the path where Multer stored the image. And this is the path we can then use in the front end. With this added on the back end, we can now work on the front end to use this REST API endpoint. And this also shows you that you can use REST and GraphQL concepts together. It's not like a hard decision you have to make. You can use the best for a given problem. So now we can use that on the front end, and we want to use it in this finish added handler. So the feed.js file of the React app, in the finish added handler, there I'm preparing some form data. And this form data does not get a title and content anymore, but it will still get the image. Additionally though, I also want to check if we are in edit mode. So if this state added post, if that is true, and then I will append the old path field, which is this state added post, which is the post we're currently editing, image path. This is a field we're setting when we're loading all posts. There, when we load all posts, we also set the image path. And this is a field which we therefore also should set when we edit our post. So there, when I create a new post, I should also add image path here and get that from create post. That should be my image URL, which I get there. And that is also something I need to request. Therefore, image URL is something I do request here. So I do have it available. So I'm setting this image path. I have that available. This will be the path of the old image on the server. And now with that, I have my form data set up. Now, before I send my GraphQL query, I will therefore send another query to HTTP localhost 8080, but there to /post image, so to this new endpoint I defined. And the method here will be put, because on my backend here, I simply defined this to handle put requests. You could, of course, also argue to use post, but since I'll replace the old image, put makes a lot of sense. I'll then add my headers. Now, regarding authorization here, we want to make sure that our auth middleware actually runs first on the server so that we know if the user is authenticated. And if isAuth is false, then we can certainly throw a new error here, not authenticated, so that we protect this route as well. So now on the front end, we need to add our authorization header, and I will just copy the headers from my GraphQL request because the headers actually are the same. And the body is now here my form data. This fetch request will be made first. Then, after it has been made, I'll get back a response, some response data, where I'll parse the body. And thereafter, I'll have my file response data. You can name this however you want. And in here, I now can extract the image URL by accessing file response data and their file path, because in my endpoint, I am setting this file path key here. And I can now use that in the GraphQL query. So now let me grab all that GraphQL code here, this code up to the then block, cut it, and move it into this then block, and then remove this semicolon and chain this then block here. I just need to return this fetch call so that the next then block refers to the result of this fetch block here. So now I do have my image URL. Now I just need to pass it here for my GraphQL query, image URL. And now we should have a setup where we are able, for now, to at least create new posts. Editing is something we'll work on later. So let's try that out. Let's try creating a new post. And first of all, on the server, I'll clear all the images in the images folder so that we can tell whether this works or not. So back here, I need to log in again. Let's quickly do that. And let's create a new duck, a new post, but it can be a duck with an image, hopefully. Let's choose our duck JPEG. This is a lovely duck again. Accept. And I get this error regarding payload too large. This is actually coming from an error on my side. That fetch request here, where I send to post image, I should not set the content type to application JSON there. Otherwise, it will be parsed as JSON data, and that does not work for my binary data here. So, after removing this header, let's try this again with another duck here. Add that image. So lovely. Accept this. And now it uploads this first, and we can prove that by looking into images. Here's our duck image. So this works, and it still creates that post, which we can see here. Next challenge is to make sure that we can click that view button and view the detail page for one post. And this again is a challenge for you. Implement something, some schema or a query in the schema of your GraphQL API and add a resolver that takes the ID of a post and loads that post. You can then work on the front end too if you feel bold. Otherwise, focus on the back end. We'll do it together in the next lecture. Now, what is GraphQL? To really explain it, let's compare it to a REST API, which we already learned about. A REST API is a stateless, client-independent API for exchanging data. So it's a Node Express application, or Node with any framework application, of course, that we build to exchange data. We don't render views, we don't store sessions, we don't care about the client, we only get requests, parse the data, and return responses with data, typically JSON data. A GraphQL API is generally not that different. It's also a stateless client-independent API for exchanging data, but, and that is the important part, of course, with higher query flexibility. And to understand that, let's have a look at some REST API limitations. Let's say in our REST API, we have an endpoint that looks like that. We can send a GET request to /post, and as you might imagine, this would fetch us a post, let's say from the database, but could also be from a file or anything like that, of course. And this is how a post might look like. Now, we return that to the client and everyone is happy. But what if we actually only need the title and ID on the client? What if we don't need the content or we don't need the creator data? We can, of course, have many scenarios where we use one and the same endpoint in our front-end application, so in our single-page application or our mobile application. And in one place, on one page, we might need title and content. On the other page, we might need content and creator. How can we solve that? Well, solution one is, of course, to simply create more endpoints that return the different types of data. We can create a new REST API endpoint, for example, sending a GET request to post-slim to only return title and ID. Now, obviously, by the way, you could also, of course, use the same endpoint all the time and just parse or filter out the data you need on the front end, but then you're sending a lot of unnecessary data over the wire, which is an issue, especially when working with mobile devices. So our solution could be to simply create more endpoints that simply return the data you need for each of these endpoints. The problem is, you'll have a lot of endpoints and you'll have to update them continuously, and you also have a very unflexible solution here. If your front-end engineers, and in bigger projects you typically work in different teams, if they need more data on a new page, they come to you as a backend developer and ask you to give them an endpoint that returns that data. And they're stuck in their front-end development until you added this. So fast iteration on the front end is made harder. And on the other hand, you on the back end continuously have to add new endpoints to cater for the needs of your front end engineers. So this is not really ideal. Solution 2 could be to use query parameters. On your existing endpoints, you could accept query parameters like data equals slim. Now, obviously, that is an option, but just as with the first solution, you always have to add it so that your front-end engineers can continue, and you have this dependency between front-end and back-end. Additionally, your API might become pretty hard to understand because it might not be clear which query parameters can I set, which values can I set on these query parameters. So this is also not ideal. Ideal for apps where you often have different data requirements on different pages is to use GraphQL. There, you don't have the problems I described before, because there, as you will learn, you have a rich query language that you use in your front end to send it to the backend, which is then parsed on the backend and dynamically retrieves just the data you need. So it's almost like a database query language, which you use on the backend, like SQL or MongoDB query language, almost like something like this for the front end, so which you put into the request you send to the backend. Now, that is the idea, but how does GraphQL work then? Well, we got our client, we got our server, and on the server you generally have your logic for interacting with the database, with files, anything like that. Now, what do you send from client to server? In a GraphQL world, you only send one kind of request, and that is a post request to GraphQL/GraphQL. So you only have one single endpoint where you send your HTTP requests to, even for getting data. And why is that? Well, for a post request, you can add a request body, and that request body will contain that query expression. GraphQL defines its own query language, and I will show you where to learn more throughout this module, of course. And you use that query language, you put it into the request body, and you just can't send request bodies on GET requests, for example. So you put your query language expression into that request body, and that will be parsed on the server to then do some magic on it and return you just the data you want. That is the idea behind GraphQL. Now, such a GraphQL query would typically look something like this. It's a JSON object-like structure where you have an operation type. Query would be for getting data. You also have other types like mutation for editing or deleting or inserting data, or subscriptions for setting up real-time data subscriptions using WebSockets. You also have the endpoints, you could call them, or the commands you can execute, and you define them as a developer on your backend, the available endpoints. And then the fields you want to extract. And that is the flexible part, because you could, in one place, get the user with just a name, and in another place, you could get name, age, and email. So that is exactly what you put into your query, which you send to your backend, which is then parsed there. Now, regarding these three operation types, as I mentioned, we got a query. There, we retrieve data, and we use a post request for that. But if we want to compare it to the REST API world, then this would be your equivalent to sending a GET request to some path there. We also got mutations, which basically are used for everything that changes data. So what you previously handled with post, put, patch, and delete requests. And subscriptions, as I mentioned, set up real-time connections via WebSockets. We'll not focus on that in this module because this is no GraphQL course. And indeed, you can create whole courses on GraphQL. Here, I want to focus on the core features. So to sum it up, in a big picture, we have our client. We send a request to that single GraphQL endpoint on our server. And then there, and this is the part you will do with me in this module, there you set up your definitions for queries, mutations, and possibly also subscriptions. In these definitions, you use type definitions because GraphQL uses a typed query language, which means you define the types of data you work with, the types of data you return in a query, and so on. And these endpoints you define here, so these queries and mutations and subscriptions you define, these are connected to so-called resolvers, which are functions that contain your server-side logic. And if you compare that to a REST API, the definitions would be your routes and the resolvers would be your controllers. And that is how you can look at GraphQL, and this is how we will implement it. So to sum it up, it's a normal Node and possibly Express server. Of course, you're also not limited to using Express.js. You're also not limited to using Node, by the way. The GraphQL language or approach can be used with any programming language, just as REST APIs could. But this is a Node course, of course, so we'll focus on that. You have one single endpoint, typically /GraphQL, though you could change this, of course. You only use post requests because you put that query expression into the request body. And you have resolvers on the server side that analyze that request body and then do something with your data based on the query expression you had in that body. And we'll use third-party packages for that parsing and so on. So posting for getting data, that is the most confusing thing you typically have when diving into GraphQL. Yes, this is what we do. This is what is okay here because we describe the data we want to get in the request body. Now that was a lot of theory. Let's see it in action. So let's make sure we can also fetch a single post. And for that, I'll go to my schema again, because on the schema is where I will work. And so here, I will add a new query, post, which will get an input, an ID, of that single post I want to fetch, and will return a post in the end. This is how my query should look like in the schema definition. Now let's of course also add a resolver for this single post. For that, I'll go to my resolvers.js file, add it down there, use the async function syntax, like this. And in that function here, just as in the function up there, I'll get arguments in the request object. With object destructuring, I can get my post ID, or whatever you chose as a name here. So in my case, just ID. Out of that request arguments object, I get the request object as well. And first of all, I can check whether the user is authenticated. So I'll copy this check and add this here. And then as a next step, I will add the logic to retrieve a single post. And for that, I'll get my post by awaiting post find by ID for the ID I get as an argument. Now I will also populate the creator here so that we have all the user data and not just the ID. And thereafter I'll check if we did not find a post, in which case I'll create a new error, no post found. And I'll set a code of 404 and throw that error. But if we make it after or past this if check, we know we have a post. And then I'll return an object where I get all the data from that post. And then again, I override the ID because I can't return object IDs. So post underscore ID to string. And the same for created at because I can't return dates. Created at to ISO string, and updated at will also be changed to ISO string. With that in place, I have everything I need to fetch a single post, I'd say. Let's now go back to the front end and wire that up. And there, I'm interested in a single post in the, well, single post page here. In there, in component.mount, I'm sending my request. And I'll, again, adjust the URL to go to localhost 8080/GraphQL. The method here will be a post request. For the headers, I add my content type application JSON header. And I will need to prepare my GraphQL query here, which is, as before, an object with a query key. And then the query is surrounded by these backticks. And in there, well, I want to reach out to my post query. I will send my ID. So my post ID I get up there should be surrounded with quotation marks. And regarding the fields that I'm interested in, well, thereafter I use the creator name, the title, the image, URL, the date, the created at date to be precise, and the content. So I want to fetch that. I want to fetch the title, content, image URL, creator, and for the creator only the name, and then also created at. That is what I'm interested in. And this is now what I will append as a body to my request. So JSON stringify and add this GraphQL query here. With that, we are sending that request. As you learned before, handling the error there will not really work. We want to handle that error after we parsed the response data, and then we can check for errors. So I'll copy that logic from feed.js into single post.js here, where I check if we have any errors, and then I throw an error. If we have no errors, we just need to drill into the response. And for that, you must not forget how your schema looks like. We'll have data, then we have that name of the query, which is post, and then we can access our different post properties. So here we access rest data.data, and then indeed .post.title and so on. So just .data has to be added to all these places where I extract some data. And with that, I should be able to load a single post. Save that and make sure your backend is saved. And click on View. And it looks like I have an error in my URL. Yes, this colon needs to go. Now let's click View. I get user login failed. That is the wrong error message I copied there. Fetching post failed. But somehow it fails. Let's quickly check what's wrong. Yeah, there is a syntax error in the query. We need to have surrounding curly braces around the overall query. So edit your query to have a opening and closing curly brace right at the start and end. And thereafter, if you click on a single post, now you load the post data there. So this is now working. What's missing is a possibility to edit and delete posts, and of course to work with the user status. So let's work on that next. Now that we can load a single post, let's make sure we can also edit a post. And as always, that journey starts on the backend. There, in the schema, we want to add a new mutation, because obviously editing a post is a mutation. I'll name it update post, and I expect to get the ID of the post I want to edit, and then some post input, which is my post input data. So the exact same data I expected to get for creating a new post. As a result, I will return the updated post. So this is my schema. Now on to the resolvers, where I will add update post as an async function again, where I get my arguments. I will have the ID and the post input and the request object. So this is my update post resolver. In there, I first of all want to check the authentication status and throw an error if the user is not authenticated. Hence, we can copy the code from our other resolver functions where we had a similar check. And then I'll first of all get my post, by using await and post find by ID, and using that ID I extract as an argument. I'll also populate that with the creator so that we have the full user data when we return the updated post. Then I'll check if we don't find a post, and I can copy that check from up there to return an error in that case. And if we do have a post, well, then I want to check if the user who tries to edit it is the user who created it. And for that, I'll check if post creator underscore ID to string, if that is equal to request user ID. And that also converted to a string. If these two match, then I know this user is the creator. If they don't match, so if I add exclamation mark here, then I know someone tries to edit the post who's not authorized to do so. And in this case, I'll again create an error, not authorized. Could be the error message we throw. I'll add a code of 403 and I'll throw that error. And then we can't continue. If we are the right user, however, we can now edit the post and set the title equal to post input title. We could now also add validation, by the way, and we should. So I can scroll up to my create post function and grab that validation logic, all the logic beginning from the empty array being set up to the errors being checked. And that is something I also want to do before I start editing my post title and so on. But now here I know that the input is valid. So now I will edit my title. I will edit my content. And I will now also edit my image URL if it changed. And that is not guaranteed because if the user did not select a new image, the image will not have changed. So I'll check if post image URL is unequal to undefined. And now this has to be checked against the text because it will be converted to text. By the way, I'm sending it on the front end. So if this is undefined, then I will continue. But if it is not undefined, then I'll also overwrite the image URL with the new image URL, of course. Otherwise, I will not touch the image URL. And then I'll have my updated post by awaiting for post save. And I will then return my updated post here or some data. I will return my updated post doc data and again replace the ID with updated post ID to string, and the same for the dates. Created at will be replaced with updated post created at to ISO string, and updated at will be replaced with updated post updated at to ISO string. So this is the response I want to send back to my client here. With that, we got a resolver in place. We hopefully got everything in place we need. Let's now go on to our React application. And there, in feed.js, we need to find finish edit handler. So if we scroll down, in this function, in the finish edit handler function, we will always send our image to that endpoint. Though, of course, it could be the case that there is no image to append if no new image was chosen, but that will be fine. We do handle that scenario in our endpoint, right? In post image, we check for the existence of a file and we send a response if no file was provided. So thereafter, here we continue and we'll have a file path, though that file path might very well be undefined. And that is why in my GraphQL API, I check for it being undefined. We could handle this in different ways, of course. We could alternatively simply keep the old file path here then, if this is undefined. But I will go with this approach. And then we send the GraphQL query. Now, of course, it will not always go to create post, though. It might also be that we added a post. So I'll check if this state edit post is true-ish, which means we are editing. And then I'll set GraphQL query to a different query. So to an object where my query then looks differently. I will copy this query in general. So I'll copy all the code between my opening and closing backticks, like this. But of course, I'm targeting update post here and not create post. So I'm targeting this mutation here. And there I also need to pass in different data. I need to pass in my ID, which I get from this state edit post underscore ID. I still pass in the post input as before. That did not change. And I still want to get the same data back. So that also does not change. Then we send that request. And in the handler of the request, I already have some logic that should handle this correctly if we are updating. So let's save that all and let's give it a try. Let's reload and let's edit another duck and add a couple of exclamation marks without adding a new image. And I get an error here. In general, though, it looks like it worked. I have my exclamation marks here, and the image, the old one, is also still there. I can also still view that, and here I see the change too. Now regarding that error, well, that is related to how we extract data from the response. We access create post, but of course, if we send an update post request, then this field in which our response data is stored will be named update post and not create post. Therefore here, and we can, by the way, validate this here, it's stored in update post. Therefore, what we can do is we can add a new variable, response data field, or whatever you want to name it. And by default, that should be create post, because creating a post also is our default query up there. But then I'll add a if check, and I'll see if this state edit post is truish, in which case the data field where I want to extract the data will be update post. And now we just need to use that variable here to dynamically retrieve our data. And we can do that by selecting all these create post instances here with the first dot and replace them with square brackets where we pass in rest data field. And this will now use the value inside of rest data field to access, well, a property with the name of that value on our data object. And now if we reload, we should be able to remove the exclamation marks and try out choosing a cup as an image here, except no error, and we see the cup here too. So this all seems to work. The status and deleting of posts are the remaining things that don't work. Let's finish the post functionality by making sure we can delete posts. And as always, feel free to do that on your own as a practice. Create the appropriate query or mutation and the respective resolver functionality on your own. And feel free to edit the front end too. After a short pause, which you can use to pause the video and try it on your own, we'll do it together. Were you successful? Well, again, we start in the schema of our backend, and I'll add the delete post mutation here. And I expect to get the ID of the post, which should be deleted. I will then only return a boolean that indicates whether that succeeded or not. This is my mutation. More interesting is the resolver for that. So let's go to the resolvers file here, and there I'll add delete post. I'll retrieve the ID from the incoming data package, so to say, from the arguments object, and I'll write this in the async function syntax again so that I can use async await. And again, I'll start by checking the login status. Now, obviously, you could refactor this into a common function. I deliberately have the more verbose setup here to make it really clear that we have this check in every of these resolver functions. After knowing that the user is signed in, let's fetch the post we want to remove so that we can check whether the creator of the post is the user who tries to delete it. So we get the post by awaiting for post, find by ID with the chosen post ID. Now here, we can check if we don't have a post. And again, this is some logic we can copy from before. And the same is true for our authorization check regarding the equality of the creator and the logged in user. So I'll copy these two if statements in here to check if the post exists. And then I want to compare the creator with the logged in user. Now important, since I don't populate my creator field here, the creator here is not an object with _ID, but creator itself is already the ID, because that is how it's stored in a post. And we need to call populate to change that in the result. We're not doing that here, so we only access creator to directly get the ID of the user who created the post. Now we got all the checks in place we need. And after this, we want to delete the image that belongs to that post. Now for that, I have that functionality in app.js here. Now I will copy that and put it into a separate folder, util, where I will add a file.js file. And in there, I will just import path by requiring path, and it will import the file system by requiring that core node module. Now in here, I can export clear image so that we can use it in our files. And I want to use it in app.js, where I already did use it in the past. There, I don't need the file system import anymore, but I will add an import to my own clear file functionality by requiring util file. And then here I use destructuring to get that clear image function. So this is now using that restructured code where I moved that function into a separate file. And in the resolver, I can now also import that. So here I also want to import clear image by requiring, and here I need to go up one level, then the util folder, and then the file. So now I have clear image available. And now at the bottom of my resolvers, in that delete post resolver, here, I will call clear image and pass my post image URL in there, because that is the path of the image on my server. Now after this was done, I will await the result of post find by ID and remove. And I'll do that for my post with that ID. Once this is done, I just need to make sure I remove that post from my user as well. So for that, I first of all need to get my user by awaiting user find by ID for the user ID stored in my request object due to the auth middleware we added earlier. And on that user, I can then access the posts and pull my ID, so the ID of the post which I just deleted. And thereafter, I will await the result of user save to save that updated user back to the database. And then I will return true, because remember, in my schema I defined that I want to return a Boolean. I could wrap this all with try catch, this part, to also then return false if it fails. And that is generally something we can do on all these resolvers. I will not do it here to keep this code a little bit more simple, but in the end, that is something you could add. Important is that you here return true. That is the backend. Let's now work on the front end as well, and let's make sure we can trigger the deletion of the post there. For that, in the feed.js file, you want to go to the delete post handler, and there again, define your GraphQL query, which has the shape you already know and love. In that query here, I'll run a mutation, the delete post mutation. The ID here is injected between double quotation marks. It's the post ID I am getting as an argument. And we have no nested object here, so we couldn't even get any nested or detailed data. We only get true or false. That is my query. And then here, again, I'll send this request to localhost 8080/GraphQL. The method, as always, will be a post request. We add our token. We also set the content type to application JSON. And of course, we need to add our query expression as a body by using JSON stringify and passing our GraphQL query in there. We don't handle errors like that, as you learned. Instead, we do it on the parsed response, because that is where we would have an errors object if there are any errors. So I'll copy that code from above and then move that in here to check if there is an errors object, which means something did go wrong, and then deleting the post would fail. And that is it. Now let's save that as well as the backend code. And let's click on delete here. And that is looking good. And I can carefully delete all my data unless there's only until there's only one duck left. And if I now refresh my posts, only one duck is there. And in users, that user still has 2 ducks or 2 posts. But that is probably related to something I deleted earlier behind the scenes, which is also the reason why I have 2 images here. To validate that everything does work, let's delete that. And on that user, let's manually delete the 2 array elements, clear all the posts as I mentioned, clear all the images here. And now I'll reload. We have no posts now. Let's create a duck and let's give it that duck image and some content. Let's also create another item, a cup, and give that the cup image here. We can now view the cup, we see it. We also see the duck here. Now let me delete the duck. The cup is still there. Only one image, this is looking good. If I inspect my users, only one item, the cup, so that now makes perfect sense. And now let me also try logging in with a different user who didn't create that. And their deleting indeed does not work. So we have all that in place. Let's now finish this all up by making sure we can view and edit our user status. And again, this is a great challenge for you. We're almost done. Let's now make sure we can also view our user status and delete it. And as I already mentioned at the end of the last lecture, this again is a great practice for you. So definitely feel free to try this on your own first. Pause the video now and implement these 2 functionalities. Of course, we'll also do it together after a short pause. So, did you succeed? Well, let's try it together. And I'll do both in one go. I need to add 2 things, one query and one mutation. The query is for getting the status. And actually, since we're not using the approach I mentioned earlier, where we add a new endpoint for everything, we have to remember that with GraphQL, we can control which data we get back. So I will add a general user query without any arguments, always for the currently logged in user. And I will return a user object here. Now, in my mutations, I will add my update status mutation. I could add an update user mutation if I generally would be fine with the user changing. Since I have no such functionality planned in my app, I will only add a special mutation for just the status. Otherwise, we could, of course, go with a more generic approach here too. There, I expect to get the status as a string, and I will return the updated user. With that, we can move on to our resolvers. Let me add the code for returning a user, so for this user query. There, I get no arguments, so I get that object, but I will not retrieve anything from there. And again, I will write this as an async function to be able to use the await keyword. I'll then check if the user is authenticated. If he's not, then, well, we have a problem. And I will not continue. Otherwise, I will get my user by awaiting for user find by ID. And I can use the user ID stored in the request. And on that user here, I'm interested in the status, right? That's the status I want to return. So if I find no user for that ID somehow, then I will basically do the same I did when I found no post. I'll return an error, no user found. If I do have a user though, then I will simply return a response. And that is my whole user data. I just will make sure to replace the ID with user_ID toString. So I can now theoretically fetch all the data about a user I'm interested in. But obviously I'll implement that in a way that I only fetch the status. And that is something I do here in my feed.js file of my frontend application. There in component didMount, I send a request to an endpoint which does not exist anymore. Instead, we're now, of course, targeting GraphQL. The method here will now be post. I will send the token, but I'll also set the content type to application JSON, and I'll set the body to my query. And that query is something I need to create up there. GraphQL query is a constant I'll create here. That is our object with the query key, which again is surrounded by double backticks or single backticks, but I need two, opening and closing. And here I'll send my request to my user query, or I'll use the user query. And all of the data I get back, I'm not interested in the name or the email. I'm only interested in the status. That is my GraphQL query, and that is what I'll send in stringified version to that endpoint. Again, handling errors like this will not work. Let's instead grab the code we have below here, where I just check for the existence of the errors object after parsing the request body. So here, fetching status failed would be my error message. And when I extract the data, I need to drill into the data field and then the status field. Now, if I save that and I reload, I got an internal error here. Cannot return null. Let's quickly check our resolver, the user resolver. I return my user object here, but I did not save it, I guess. This now looks better, but I'm not seeing the status here, and I got an error, about which I'll take care in a second. My status here is not found in data. I have to drill into the user field as well. We can see that if we go to the network tab and have a look at that request, where we got that data, we got data, and in there, user, which is the name of our query, of course. And I forgot that, but obviously, query name is always where the data is stored in. And that then has the status field. So this is a change that is required. And now with that, we see the status, and this error message also is gone. Like that. So this is it. Now let's also make sure we can update a status. And for that, let's first of all make sure we do something for this schema we added, for the update status schema in our resolvers file. So this is the last resolver function I'll add here, update status. I'll get my status argument and the request, of course. And I will, as before, use my async function syntax. And in here, I first of all will check whether the user is authenticated. If that's not the case, we throw an error. And then I'll get my user by awaiting for user find by ID for the request user ID, so for the logged in user. If I have no user, then we got a problem. So I will copy that code from above and throw an error if that's the case. Otherwise, I'll set the user status to the new status I'm getting as an argument, and then I will await user save to save the updated user. I can then return an object where I take my user doc data and where I replace the ID, so user ID, with the stringified version of it. And this is my update status mutation. Now, last but not least, I also need to edit this on the front end. So in my React app, and there we simply search for the status update handler here, where we of course send a request to GraphQL, and that should be a post request. The headers are all right, and I will define my GraphQL query here is an object, the query key, my backticks of course, and the query now is a mutation with the name update status or whatever you defined in your GraphQL schema file. And there I need to pass in the status, which is a string. So we need double quotation marks around the value, which I'll now inject here. And the value is this state status. This is where the status is stored, which the user enters into the input field. And of the data I get back, I'm only interested in the status. Then we want to send this here in a stringified version. And again, we don't handle errors here. We handle them as we do up there, checking for the existence of the errors object in our parsed response data. And that is already it. Now if I save that and save the backend as well, if I add a couple of exclamation marks and I click update, seems to succeed, and we can validate this by reloading. If I now log in with a different user, there of course we should not see that updated status. There we see the status of that user. And with that, we moved our entire REST API over to GraphQL. And I hope you see the power GraphQL gives you by being more flexible regarding the data you fetch from the backend. And therefore, your front-end development can move faster because your backend gives you the entire bandwidth of data you might be interested in. Now, finally, before we leave that module, there's one thing we can optimize now. Because there is one thing which I did in a way that is okay to do, that will work, but that is not recommended doing, and that we can do better. Whenever we pass a dynamic value to our GraphQL queries, as we are, for example, doing it here, where I do have a page, we currently do use the interpolation syntax here, where I use this $ curly brace thing to inject or interpolate a value into my string literal. Now, this absolutely does work, but this is indeed not the recommended way of adding variables into our GraphQL query. There is a better way. Maybe you also remember that for mutations we had to add mutation here, but for queries, we didn't have to add query here. And indeed, if we would have added query like this, we would have gotten an error. Well, now I will add it because now I will also add something else. I'll give this query a name that does not really make a difference. It does not make it behave differently. It will help in error messages, for example, but that name then also allows us to do something else. So here we are, of course, getting all posts. So here I'll name this fetch post, and you can give this any name you want. So this here is totally up to you. Now with this name assigned, I can add parentheses after this name to define which variables this query will use. And we create such a variable here with a $, but then no curly braces, and then the name of the variable you want to use. And that name is again up to you. I'll name it page, but you could have named it current page, whatever you want. This will be of type integer, so you assign a GraphQL type again here, and this is really important to understand. This is GraphQL syntax here. This will be parsed on the server. This is not JavaScript code that runs in the client. This will only tell our GraphQL server that we have a query which will use an internal variable. Now that I'm saying internal, the question of course is, where do we use that $page? Well, we use it in the place where we do have a dynamic, a variable value. And that would be here where we currently inject our value. Now I use my $page here, and this name here has to match this name, and it has to start with a $. And now GraphQL knows, okay, this part here is dynamic, it might change, and it will be an integer because we're defining this here. So now the only question is, how do we get our page variable here in JavaScript into our $page variable here in GraphQL? And for that, we add a second property to that query object we're creating here. Thus far, I only have the query expression. Now, after that, I'll add a comma and I'll add a second property, which are my variables. And this has to be named variables, just as this here had to be named query. This now is the query expression, and variables now is an object where we can assign values to the variables we pass into our query here. So here I have $page. Here it then should be just page without the $sign. And then my JavaScript variable or value. So I could pass 1 here to always use the first page. Or in my case, I do have that page constant or variable here in JavaScript now. So this is the value I want to assign here. Now I have page 2 times, but the first page refers to the internal variable used in the GraphQL query. And the second page after the colon refers to my JavaScript variable, just to make this clear. And now with that, let's save this and let's reload our application. Or first of all, let's quickly log in there because I was logged out. And now here you see I get my post. Now if I add another duck here, and I then add one more item so that we do have pagination going on. Then after reloading, we can indeed see that this works as before. I can switch between my 2 pages, and I simply have 2 cups in there. By the way, maybe you noticed that we didn't get that next and previous link after we created our item, our new item. That is something we can fix too. But for now, let's focus on the variables. And there, in our front-end code, this is how we use variables. And technically, it works just as before, but this is the more elegant, the better way of using variables in your GraphQL queries. So now we can replace that in all our queries. For example, in this mutation, there I also use string interpolation to get my value in there. Better would be to give this a name, update user status or anything like that, and then define which variable we need in here. That would be the, let's say, user status. Again, this name is up to you. And then the GraphQL type of that, which will be a string. Then here, without the double quotation marks, because we define it to be a string, you add user status like this. And then again, you add a second variable to that GraphQL query object, where you add that variables key, where you now assign a value to that variable you defined here, without the $sign, and then the value you want to store there. And in this case, this would be this status, just as before. Now, if I continue here in the next query, where I do edit or create a post, there I'll also give this a name, create new post, seems like a fitting name here. And there we'll have a couple of variables, which is no problem. We can, of course, have more than one. We'll have the title, which is a string. We'll have the content, which is a string. And we'll have the image URL, which is also a string. And now, just as before, we use these values in here. So title, content, and of course also the image URL. And now we just need to add that second argument here, the variables, so that we can store our title. And you might remember, this was post data title. Then the content was post data content. And the image URL, well, that is our image URL variable in JavaScript, or the constant, which I'm creating here. Now, when we edit a post, update existing post could be a name we assign to that. And there we also have some variables. And there we will need our post ID, let's say, which is an ID. We then also have our title, which is a string. We then have our content, which is a string. And now, just as before, I'll copy that value because I'll need it in a second. But then I'll replace this here with post ID. I'll replace the rest in a second too. Let me first of all add my variables below that. And then here we have that post ID, which is the value I just cut out. And then here we have the post data title and the post data content. So here we use the title. There we use the $content, not wrapped in double quotation marks. And we also have the image URL up there, which is also a string. So we should also, of course, use the image URL here. And now we need to assign values to these variables down there too. So we have the title, which is post data title. We have the content, which is post data content. And we have the image URL, which is image URL. Always remember the first part here, so the key name in our variables object refers to the variables we defined here without the $sign. The second part after the colon, so the value of our key value pairs here refers to the value we want to pass into that variable. Now, time for a little save to just check if that is all working. So now if we create a new post, another duck, because as you can tell by now, ducks are lovely animals. It's still lovely. If I accept that, then we seem to have an issue here. So that did not work. And the problem we have here can be found when I inspect my GraphQL request, which fails. There I get some errors. We see that all my variables here of type string expected a type string which is required. And that, of course, is my mistake here. We should add an exclamation mark here, because if we have a look at our backend, at our schema here, we have a look at our mutations there, then we can see that create user has user input data and create post has post input data, and that is what we're working on. And that input data, the post input data, indeed does require all these strings. The page previously was optional. There we had no exclamation mark, which is why I did get no such error before. For the status, by the way, we would also get an error because the status, as you can tell, also has a required string. And that is really important, and therefore good that this slipped through. The types you assign in your frontend here for your variables have to match the types in your backend schema. So here, for example, in create new post, all my strings here are required. And for update existing post, well, there, for update post, we also have the same type of data and a required ID. So we should make sure that we add that exclamation mark after all these values here, because they are required in our schema. They have to be required in our front end too. So let's add this also on update status. So after this change, let me go back. Let's try this again with another duck. Entering some dummy value here. And now this is looking better. Now let me edit this by removing the exclamation mark. And there I still get an error. Image URL was not provided. Let me quickly have a look at what's wrong there. If we go to our update existing post, I do have my image URL here. And on the back end, an update post, I also do require it there. But indeed, the problem I have here is that the image URL is not always set when we don't choose a new image, right? And you might remember that indeed on our backend, we have a check in update post where we see if that is undefined as a text. So I should at least pass that text in to go through that check. So what I'll do is, if my image URL cannot be set here, I'll set it to a string undefined, which is not the same as the default value of the type undefined. And with that, if we now reload and I tried it again, now that works, because now we're setting this to a value we're checking for in the backend for the use case that we don't have a new image. And then we'll keep the old image here. With that back in the front end, this is taking good shape. The other queries in feed.js are all right. In the single post JS file there though, here I also have a query where I inject a value when I get a single post. So here I'll give this a name by adding query and then name, fetch single post. And there I expect to have a post ID, which will be of type ID, and that is required because it is required in our backend schema. Here in our post query, we do require that ID. And then here I can also assign that here. And as you learned, add a second element to that GraphQL query object, the variables property where I then set post ID equal to post ID. So to this post ID, which I'm extracting here. And now if I save this and I go back and click view, this still works without issues. Now with that, let's also go to app.js in our front-end code, because there we do sign users up and in. And here we also inject values into our query. Now, just as before, we should name these queries and use that different approach. So here I'll name that user login. And I do get an email, which is of type string and which is required. And I do get my password, which is of type string and required. And then here, where I have auth data email and auth data password, I can use email, so $email and $password. And we add that new variables object here as a property to the GraphQL query, and then email will be auth data email and password will be auth data password, just as before, but now with that more elegant syntax. And last but not least, when we sign up, so when we create new users, then I'll also give this mutation a name, create new user, whatever you want. And here, again, I expect a couple of values. I expect the email, which is a string and which is required. I expect a name, which is a string and which is required. And you can always check your backend schema to learn what is required and what is not. And here, our user input data is what we have to pass to the backend. So last but not least here, I also have my password, which is a required string. And then I'll just quickly copy that, because now I'll replace these values with my GraphQL variable equivalents. So $email, $name, and of course here, $password. And then again, add that variables object and pass email, which is auth data sign up form email value, pass the name, which is auth data sign up form name value, and pass the password, which is auth data sign up form password value, just as before. And with that, we should have replaced all injected values in our application with new values. Now let me quickly sign up with a new user here. Now let me also quickly log in with that user. And that also works. And with that, we got everything in place. I can't delete that, obviously, because I'm not the user who created it. I would have to log in with the correct user for that. So with that, everything is working the way it should. And now we have a GraphQL API that uses that new variable syntax, which is the recommended way of passing dynamic values into your queries. Now, there's one thing you also might have noticed. When we only have 2 posts, so we have no pagination because we don't have enough posts to have a second page, and I add a new value like a duck here, then this duck will show up, but we don't get that next button. There is a little bug here, which is easy to fix, has nothing to do with Node.js, but it is really easy to get rid of. In our finish edit handler here, when we go down to the code where we create that new post and we then add it to our existing posts, it's this else block here, which is interesting to us, where we in the end make sure that we only render 2 items at a time and that we add our new post at the beginning of the list. Now here, what I need to do is I need to make sure that I do increase the amount of total posts. In our state, in React here, where we manage how many posts we have on that page, I do set total posts here to a different amount of posts when I fetch all posts, where I get that total posts information. Well, when adding a new element, I know that total posts will simply be the old total posts plus 1. So I will add a new variable here right below updated posts, and that's updated total posts, and that will be previous state total posts. And that is a bit of React logic here, but this first of all takes the old status. And now, when I do go into the else block, which is the case when I am not editing, but when I'm adding, then I want to set updated total posts plus 1. With that plus plus syntax, I increment it by 1. And then here in the return statement, I'll set total posts equal to updated total posts. And with this change in place, if I now quickly delete my duck again so that I'm back to 2 items, and I do add my duck so that I go up to 3 items again, now you see that next button, and you can use it, of course, because now we're managing the total post correctly too. So that's just a little adjustment, has nothing to do with Node or GraphQL, but since I spotted that bug, I of course also want to get rid of it. And with that, we moved our entire REST API over to GraphQL, and I hope you see the power GraphQL gives you by being more flexible regarding the data you fetch from the backend. And therefore, your front-end development can move faster because your backend gives you the entire bandwidth of data you might be interested in. That was a lot of content on GraphQL. And as I mentioned, you could fill an entire course just on GraphQL. And indeed, there are courses on it. The official docs on graphql.org are a great place to dive deeper because they're really good, and there you can learn more about all the features GraphQL offers, including its more advanced features. In this introductory module, I hopefully gave you a good overview over the GraphQL core concepts and how you build a GraphQL API with Node, and in this case with the Express.js framework. You learned that GraphQL allows you, or is a technique to build a stateless client-independent API, just as we did it with the REST API, but that it offers a higher flexibility than REST APIs typically do, because you expose a custom query language to your client. A GraphQL API is made up of queries, which you would compare to your GET requests in REST APIs, mutations, that would be your post, put, patch, and delete requests in REST APIs, and possibly also subscriptions, something I didn't cover in this module. You use these constructs to exchange data and to manage data, and the important and characteristic thing about GraphQL APIs is that they only expose one endpoint to the client, and that is a post request to /GraphQL typically. It has to be a post request though, that is something you can't avoid. And all requests are directed there, and then in the request body of that post request, you use the GraphQL query language to describe the query you want to execute or the mutation you want to execute. The server parses that incoming query expression and then calls the appropriate resolvers to execute the logic you wrote and return the appropriate data or do the appropriate manipulation. GraphQL, and that is also important, is of course not limited to React.js front-end applications. You can use it with any front-end application, be it a mobile app, a single-page app with any framework, or whatever you have. It's not limited to React. Now, when we compare it to REST, then we have to understand that REST APIs are not strictly worse. They might still be the perfect solution for your next project. They are especially great for static data requirements, so where you don't need that additional flexibility. And then you have a very clearly structured and explicit way of defining your endpoints and defining the possibilities your API offers. So for file uploads or scenarios where you simply don't need that flexibility because you always get the same kind of data, there REST APIs might still be the perfect solution. In other scenarios, GraphQL might be better because you get a higher flexibility due to that exposed full query language your client can use. And I also want to highlight that both REST and GraphQL APIs can be implemented with any framework and actually even with any server-side language. You're not limited to Node.js, and on Node.js, you are of course not limited to Express. And that is really important. The core concepts you learned here and a lot of the logic you applied will actually be the same no matter which framework you use or no matter which server-side language you use. We added our first GraphQL query, which allowed us to get data. Let's now add a query that allows us to save data. And for that, why don't we start with our front end, which we used, and make sure that we can actually sign up users so that we can create users, because that sounds like a mutation to me. For that, first of all, let me clean up my front end. I'm not using socket.io there anymore. So in the feed.js file at the top, remove that open socket import. And then let's remove that logic from component did mount, where I created my socket connection. And let's also remove add post and update post. I'll do that differently later. After changing this, let's go to app.js, which is where we do sign up. And we want to make sure that for the sign up handler, we now reach one of our mutations. And for that, we first of all need to create it. Now, how do we create a mutation? I'll get rid of this resolver. We'll later add query resolvers again. For now, I will get rid of my query here. For now, I only need a mutation. And we add that now schema by adding mutation here. And then just as with the query, we define a type, which you could name mutation or root mutation, whatever you want. And there you now define the different mutations you want to allow. So here I'll just point at the root mutation. And in the root mutation, I'll add one which I'll name create user. You could name it sign up, you can name it whatever you want. Now that mutation here will actually require some input, some arguments. And that is a different syntax which you now haven't seen before. You can add parentheses after your query name. And this allows you to specify arguments that have to be given to that resolver that will run in the end. And here we could define that we need some user input data. And now we need to define the type of that data. So how does this data look like? Well, first of all, we could of course accept the title of type string and then another argument, which is the email of type string, and then another argument, which is the password of type string. That would work too. Or we bundle it in one object, which we expect. And for that object, we can create a new type. And we don't do this with the type keyword, but there is a special keyword for data that is used as an input. So for data that is used as an argument. And that is the input keyword. And you can now name this however you want. I'll name it user data. And there, how does my user data look like? Or let's name it user input data maybe. How does that look like? Well, that will be an object which has an email field, which is a string that is required. I need that to be a string and I need that field to be there. I also will get a name, which is a string, and a password. Now, this is the data type I'll use here for my argument, create user. And now the question just is, what do I get back after a user was created? Well, there I want to get back a user object. So for that, I'll define a new type, not an input, but a normal type, which I'll name user. There I'll have an underscore ID field, which will be an ID type. It's a special type provided by GraphQL, which simply signals that this is unique and, well, treated as an ID. I'll then also have the user name, which is a string. I'll have the email, which is a string. I have the password, which is a string, which I don't require, let's say, because I don't necessarily need to return that. I'll have a status, which is a string. And I'll have my posts. Now that will be an array, and for that I also need to define how my posts should look like. So let me define another type here, the post type, and that will have an ID. That will then also have a title, of course. A post will also have a content. A post will then also have an image URL. And of course, you might notice some similarities to my Mongoose models. There I also defined how the data will look like and how it is connected. We're essentially doing the same here, because this will allow us to then retrieve that data efficiently. So now I have my post image URL. We also will have a creator, which is a user object, and we'll have the created at field. Now, GraphQL does not know dates, so I'll use a string here, and the same for updated at. Remember, we'll get these two fields because in the Mongoose model for the post, we enabled timestamps. Okay, so that is the post model. Needed that because in the user type, we now will have an array of posts. And this is how you tell GraphQL that you have an array of something. You enclose it in square brackets. And that user data is now what I want to return here when I create a user. That is the schema defined. Let's now work on the resolver for that. We have the create user schema. Let's now work on a resolver that allows us to create a user. And for that, in the resolvers file, I'll add create user like that. And now here, I actually get some arguments. You also do so in queries where you get data, by the way. There, you could also get arguments. For example, when you want to retrieve a specific post with a specific ID. Here, my arguments are no post ID though, but the user input data. My first argument, therefore, will be an Rx object. There also is a second argument available, which is the request, by the way. This will become important later. Now, on the incoming Rx object, I can retrieve all the data I define in my schema. So email, name, and password. That is my argument data, so that is what I can retrieve from the Rx object. Not directly on the Rx though, instead Rx will have a user input field because Rx actually will be an object containing all the arguments passed to that function. Here it's only one, but it could be more. So Rx will have a user input field, and then there I will have email, name, and password. So I can retrieve them. I can, for example, retrieve my email by typing Rx user input, because in my schema I named this field here user input. And on the user input, I can get the email. So .email, like this. This is one option. We can also use destructuring to get user input out of my Rx object. And then the email would just be user input email, so a bit shorter. Now, we'll use this in a second. First of all, let's import the Mongoose user model, because I'll still interact with the database, of course. So I will require models user. And then in here, I want to use the async await syntax. To use that, I need to change the way I write this method. I add a colon after create user and use the function keyword. And now I can add async in front of that. So now I can use async await. That is purely optional though. You could also use the normal then catch approach with your promises. Now in there, first of all, I want to find out if that user already exists. And for that, I'll get an existing user by awaiting for user find one, where the email in the database matches the email entered in the user input. Now, one super important note. If you're not using async await, you need to return your find one query, which you're executing here, where you then add then. Because if you don't return your promise in the resolver, GraphQL will not wait for it to resolve. When using async await, it's automatically returned for you. We don't see the return statement here, but it is there. So that is super important. So now I'm getting my existing user. And if I have an existing user, well, then I know I don't want to create a new one. So in this case, I will create a new error with a message of user exists already. And I will throw that error. And I will come back to error handling and GraphQL in a later lecture. If I do have no existing user with that email address, then I can continue with storing it. And the logic for that is similar to the one in my auth controller. We need bcrypt to hash the password. So in my resolver function here, let me import bcrypt at the top. And then there, we can use the hash method to hash the user input password with 12 salting rounds. Now again, I'll use async await here, so I'll get my hashed password eventually after awaiting for this to finish. Now, after I got that, I can create a new user object. And in that user object, I will pass the email, which is user input email. I'll pass the name, which is user input name. I'll also pass the password, which is my hashed password. Now I need to save that to the database, and I do care about the created user, so I'll store that stored or that created user in a constant by awaiting for a user save. And that will just return that user object it created. Now here, finally, I need to return some data. And we see which data in our schema. We need to return a user object. For that, here, I will return my created user underscore doc field, which contains just the user data without all the metadata Mongoose would add otherwise. And it will override the underscore ID field by adding it as a separate property, and therefore it will override the one I'm pulling out of underscore doc, because I need to convert it from an object ID field to a string field, otherwise it'll fail. So here I will access created user underscore ID and then call to string. This is now the user object I'm returning when I'm creating a user. Now, one important note before we actually try it in our front-end application. We can, of course, try that from inside Postman, but there is an even more convenient solution for testing this. Before I show you this solution, let me first of all clean my database though, so that we start from scratch. And for that, I'll delete both my posts and my users collection here. It will be created on the fly again once I got data to enter, and I simply want to remove all entries I have thus far. So now with the clean database, let me show you that simpler approach I'm referring to. To test this mutation, I can go back to app.js on the backend code, and there, where I register or set up my GraphQL endpoint, besides setting the schema and root value, you can also set graphical, written GraphQL, to true. This gives you a special tool, and this is the reason why I'm not listening for post requests only here, because now with your running server, try visiting localhost 8080/GraphQL, and this will send a GET request. If you enter something in the browser here, you send a GET request. And you will get this screen, which allows you to play around with your GraphQL API. Now, if you go back to your backend, to the schema, quickly add a query again to your schema here, root query. And let's create that type here real quick. And in there, just add that hello again, like this. We don't need a resolver for that, we just need that query. Now, if you reload your graphical interface, you actually have that documentation on the right here, where you see the operations you can do, but you need to have a query defined for that, even if it leads into the void. And there you can click onto it to see which mutations you have, which data you need to send, and so on. And you can not just explore that here, you can even send your data. So in here, you can now create a new mutation by typing mu, and you'll even get auto-completion, then curly braces. And now with control space, you even get suggestions. If you have more than one option, it will not be filled in automatically, but you'll get a drop-down instead. You get suggestions for what you can run. And here you now see this needs a user input, then a colon, and then an object that contains the user input data. And there you see we need an email, wrapped in double quotation marks, test@test.com. We, let's say, need a name. That could be Max. And we need that password. And that is tester. And thereafter, we add a pair of curly braces. And now we can define the data we want to return after this query is done. With control space, we get some suggestions, like the ID that was generated, or the email. And now you can run this query by pressing that play button up there, or hitting Control Enter. You also see the commands here. And this will now execute it, and it seemed to have succeeded. You see the ID of the created user and the email. And if you go back to MongoDB Compass and you refresh that here, you should have the users collection back, and you see the user in there with the hashed password. So this is a great tool for playing around, better than Postman, because you got this nice interactive support with the auto-completion. You got the documentation here, and you can test your GraphQL query in this tool in a really nice way. And now with that, let's see how we can enhance this, for example, by adding validation before we then also connect our front-end application, of course. Now we added our first mutation, and a mutation, of course, also means that we store data in the database. When something like this happens, we want to ensure that the data we store is valid. And previously in the REST API, and also in the normal Node Express application where we rendered views, we used Express Validator for that, and we added it as a middleware on our routes. With GraphQL, this is not an option, because we only have one route, this one. This is the only endpoint we have, and we certainly don't want to validate all requests in exactly the same way. So to change that and to adjust it to our needs, we want to move validation into our resolvers. There we have our endpoints, and there is the place where we can now validate our incoming request data. To do validation there, I'll install a new package with npm install and then -- save, and that is called Validator. And that, by the way, is the package which Express Validator used behind the scenes. We can use that directly in our code now. So in my resolvers file, I will import that validator object provided by the validator package. And now in create user, we can add some validation logic with simple if statements. For example, I can check if I don't have a valid email. So not validator, and then is email, and you get the same rules as with Express Validator, because as I mentioned, it builds up on this validator package. And I check if user input email is not an email address. And if that is the case, then I want to store that error. So I'll create my own errors array here, and that's just one way of handling this. You could find a different pattern, of course. And I will push a new error onto this array. And for me here, and that again is only my implementation, an error will be an object where I have a message, for example, email is invalid. Now let's say we don't just want to validate the email, we also want to check whether our password is there and if it's too short. So if validator is empty, user input password, then we have a problem because then we got no values for the password. Or we also have a problem if it's not empty, but if the length is not long enough. So if the length for the password is not fitting the criteria we specify in the second argument to isLength, which is an object where we can set a min and a max key, and I'll set min to 5. So if we enter a password that is empty or not long enough, so if it is not long enough, we need to add an exclamation mark here. Then we make it into this if statement here. And then we also have a problem. And there I also want to push an error onto my errors array. And there I'll add a message of password too short. Now this is just one way of implementing this. Now, after having all these if checks, I can check if my errors array has a length that is greater than 0, which means I do have errors. And if I do, I'll create my own new error object where I throw invalid input, or where I report invalid input, and now I throw that error. Now, let's give that a try. If I now try to add an email address, which is not an email address, and I hit play here, I indeed see my invalid input message. And that is how we can add validation. What if we now want to pass more data with our error message here? We added validation, and we see that a failing validation, and hence a thrown error, as we were doing it here, leads to a response that actually has null in the data it gives us back, but that has an errors key with an array of all the errors it gathered. If you open the network tab, by the way, and you re-execute that, You also see that it sets a status code of 500. Now that's nice, but sometimes you want to add more detailed information. You can't set your own status code though, but we could add more information to the errors we return. And to do that, you can go to your app.js file, and there where you configure your GraphQL API, you can add another configuration option, which is called format error. And this is actually a method which receives the error detected by GraphQL and allows you to return your own format. Now, if you just return error, you keep the default format, which is exactly the format we see here. But you can change that, of course. You can check if in your error here, you don't have the original error field. So if you don't have that, hence the exclamation mark at the beginning. Original error will be set by Express GraphQL when it detects an error thrown in your code, either by you or some third-party package. If you have a technical error, let's say a missing character in your query here or anything like that, then it will not have that original error. And if we don't have that, then I'll just return the error that was generated by GraphQL. But if I do have my original error, well then I can extract useful information from it that I can add in other places. And that is what we can do in the resolver now. Let's say validation fails. On the error that gets created here, I could add a data field, which is my array of errors, which I populate here with my validation error messages. I could also add a code here, which is set to 422, or I come up with my own coding system. I don't have to use HTTP status codes here. And now in app.js, I can retrieve all of that from the original error. So I can get my data from error, original error data, and that might be undefined for thrown errors that don't set it, but that's okay. I can retrieve my message directly from the error, because that is already pulled out of the error by GraphQL. And in case that should be undefined somehow, I can set this to an error occurred. And I can get my code from the original error again. There I named that code too, and I could set this to a default value of 500. Now with all that pulled out, I can return my own error object here, where I have a message just like the original one, but where I then also add my status field, which contains my code, and a data field which contains my data. And you can name all these fields in exactly the way you want. And now with that, and all the files saved here, if I hit enter again or play again, now I see I get a different error output with the data I added. And this can be very useful, and this is how you can handle errors in GraphQL. Now it's finally time to work on that React application we have as a frontend here, which you also find attached to this lecture again in case you skip the other modules. It's a React application. We'll not work on the code here too much because this is no React course. And now I'm interested in signing users up. This is done in the app.js file there and there in the sign up handler. Here we send a request for creating a new user, but this is of course a request from the REST API world. You learned that from now on there only is /GraphQL for all our API requests, and then here this has to be a post request. The type is still application JSON and this needs to be set, but the body will now be in the GraphQL query language. And for this, I'll create a new constant which I'll name GraphQL query. The name is up to you though. And this will be a JavaScript object where you need to have a query key. That is required even for mutations. The value here then is a string which you create with double backticks so that you can write multi-line string. Single quotation marks will not do it. And here you add mutation to define that you're running a mutation now. Curly braces and now the name of the mutation. The name of the mutation you want to execute is create user. Essentially, you could just copy this query here now. This is what you could copy. and which you could move into your query here. Now, of course, we need to replace these values with the values we fetch from the user input though. And we can do that by using $ curly braces in this backtick enclosed string, because this is a template literal, and this allows us to inject values. Now just make sure you keep the double quotation marks around the injected values. Otherwise this will fail, because this query language here needs to enclose strings in double quotation marks. Now the email can be retrieved just as we retrieve it down there. So we can copy that code up there. And the same, of course, also for the name and the password. So for the name, we also inject the value with $ curly braces, and we use that syntax from below. And the same for the password. Let's copy that and replace this with the injected password code. Now here, I'm retrieving ID and email. It's up to you. We don't need any of the data. I'll leave it like this. And now, this is the object I want to stringify. So my GraphQL query object. Now I don't need to check the status code here, because that will not be set. It's either 200 or 500. I'll cut it here, and I'll remove that. And in the response data then block here, where I have the parsed request a response body, there I can now check if response data has errors, and there on the first error I could check for the status field. So here I will check if response data has errors. If that's the case, I'll check if response data errors, and there the first element has a status field, just as I explained, accessing this field, and if that is equal to 422. And then I can throw my validation failed error. Maybe we have other kinds of errors, so I'll check another thing here. In case we don't throw that first error, I'll check just for the existence of errors, and there I would throw another new error where I just throw user creation failed, like this. Now after these error checks, I'm printing my response data here, and actually we should have all we need to sign users up now. So let's run our frontend server with npm start. It runs on localhost 3000. So let's open that here. And there, let's navigate to the sign up page and create a new user. Now, this is an email address which is already taken, and actually therefore I should fail doing that. Let me click sign up, and indeed I get an error, but this is a different error than you might expect. It's an error here where my method is not allowed. And this can be a tricky thing to fix if you're brand new to GraphQL. The reason for this error is we get this error actually as a response to our options request here, not to our post request. Now, you might remember that I explained that the browser sends an options request before it sends the post, patch, put, delete, or so on request. The problem is, Express GraphQL automatically declines anything which is not a post or GET request. So the options request is denied. The solution is to go to that middleware where I set up my course headers, and there I check if my request method is equal to options, and if it is our options request, then here I'll return res send status 200. So I'll simply send an empty response with a status code of 200. I return so that this code is not executed, and therefore options requests never make it to the GraphQL endpoint, but still get a valid response. And with that, if I now go back to my frontend, I clear my errors, and I sign up again. Now the user creation fails, but now it simply fails, because if we look into our data, we see that the user exists already. And that is what we expected. And now if I take a valid email address, which is not taken yet, it actually succeeds. And here is the response I get back from GraphQL, my data, that is provided automatically for the create user query, the 2 data fields I requested. And this is how we connect the front end to our backend by simply sending a post request with a valid GraphQL query expression. Now that we're able to create new users, how does authentication work in the GraphQL world? Does it work in a similar way to REST APIs? Do we use sessions again? Well, remember this slide. A GraphQL API is also stateless and client independent. So generally, we still authenticate by using such a token, which we then attach to every request that should be able to access protected resources. And a login action is, in the end, just a normal query where we send some user data and where we want to get back a token, right? So in the end, what we can do here is the following. On our backend code, in our schema, I will now define a real query instead of my dummy placeholder hello query, which I'll name login. Here, I'll need some data. And I could again define my own input, like here I did for user input data, but also to show how to use multiple arguments, I will expect an email, which is a string, and a password, which is a string. And then I will return not a user, but some data that contains, let's say, the user ID and the token, because these are the two pieces of information I happen to need here, and that makes sense as a response. Of course, you could also return the overall user object. So here, I'll define a new type. I'll name it authData, and that will be my token, which is a string, and my user ID, which will be a string. This is the data I will return when someone sends a query to log in. Now we need a resolver for this, of course. So let's head over to resolvers, and after create user, I'll add my login resolver. There again, I get my args, and I can use destructuring again to retrieve the email and the password argument, which I both get because I define both here in my login query. Again, I want to use async await, so I will turn this into an async function with this syntax. And in there, in my login resolver, the goal now, of course, is to find a user with the right email address and then confirm the password. So first of all, I'll get my user by awaiting for a user find one, where I look for an email address in the database that should match the email I'm getting as an argument. If this is not set, if the user is undefined now, I know that I found no user with that email address, and therefore I can create a new error where I say user not found or whatever you want to set as an error message. I can set a code here, just as I did it for a create user, of let's say 404 because we didn't find the user, or 401 because the user could not authenticate. I'll go with 401. And I'll throw that error. If we have passed this if check, then we know that we have a user with that email address. Now we need to check the password. For that, we use the bcrypt package and there the compare function. And we pass in the password sent with the request and the stored hashed password. Now, this is an asynchronous operation which gives us a promise, so we can await that, and I get back the is equal response. Now, if it's not equal, then I know the user entered a wrong password, so I can create a new error here where I say password is incorrect. And I can also set an error code of 401 here, and then also throw that error, of course. Otherwise, both the email exists and the password is correct, and now I can generate a token. And for that, I'll again import my JSON Web Token package by requiring JSON Web Token here. And then down there in the login resolver, I will generate a token by running JWT sign. Here you now pass the data you want to encode in the token. That could be your user ID, which you get from user underscore ID to string to convert it to a string. Maybe you also want to encode the email by getting that from the user you retrieved from the database. And the second argument to the sign method then is your super secret, which you use for signing the token, which you then also use for verifying it, something we'll do later. And I'll configure the token with the third argument by setting the expires key in that object you pass to the third argument to 1 hour, so that the token expires after 1 hour. That is exactly what we did in the REST API section 2. Now I will return that token in a token key and make sure to match that schema you defined here. So token and user ID is returned. So in the resolver, we return the token on the token key and the user ID, which is again my user underscore ID to string. And now with that, we have a login query in place where we send like a GET request to log the user in to get the token and so on, you could say. Now we need to wire that up to the front end in the next step and then, of course, test it. If you're feeling bold, also try it on your own, of course.